Well, I'm waiting, Michael.
You're waiting? What are you waiting for?
I'm waiting for the next async IO story.
Uh, I I guess it's my turn, isn't it? Okay. Sorry, let me see if I can get this right. So the topic I want to talk about is waiting in async IO. Yeah, so the magic of async IO, which was introduced in Python 3.4, never really appeared until Python 3.5 when the async and await keywords came into being, which let you write code that looks like standard single-threaded serial code, but actually is multi-threaded, or at least parallel concurrent to some degree. Depends on how you're running it, whether it's truly multi-threaded. Anyway, there's a lot of options, let's say, on how you can interact with these coroutines and these tasks that are generated by the async IO framework. And anytime there's like four ways to do something in programming, you should be asking yourself, one, why are there four ways to do this? But more importantly, when does way one apply best? And what scenario should I use way three? And what is the trade off between two and four? And so on, right? So that's the case with async IO. There's tons of ways to wait or await things. And Henning, get the pronunciation right for me. I know you got it.
I think it's no, you got it. That's good.
Yeah. Hank. Sorry.
No, it's just a running thing. I can never get it
I
right.
know. Well, the problem is I think I had it right. And then we went back and forth so many times with so many variations. Now it's broken. Uh, Sorry about messing up your name there. So wrote a great article though called "Waiting in Async IO" that does exactly that. That says here are all the ways, here's the pluses, and here's the minuses, and the situations in which you apply them. So if you're like serious about using Async IO and you're building real things, basically this podcast episode is for you because I have this and another one that bring two really cool ideas together. But let's talk about the waiting one first. So it's really easy to start doing some work, right? I can have two coroutines, let's say F and G, and I could say I want the result of F by saying, result equals await calling F, and then result G equals await calling G. And that's fine if what you're looking for is more concurrent execution of that part of code, right? So if this is, say, in a web method, like a view, someone makes a request, and there's not a lot you can do to make things go faster potentially for that one request, but you can say, let the server be less busy so it could handle like 10 or 20 times more of the same requests. Right, so this real simple, like just await calling these functions, these async functions, it will allow your system to scale more, but it won't make things faster. Like, for example, if you're trying to crawl 20 web pages, this will not make it any faster. It'll just make your code more complicated. So don't do that, right? So there's other ways in which you want to do that. Another thing that I think a lot of people don't quite get is when you call one of these async functions, like async def function name, when you call it, it doesn't actually start it until you either await it or create a task from it. So if you call like F and then G and you think you're going to come back and get to them later, now they're running. No, actually they're not unless you've created a task which starts them. So you either have to await them, which blocks, or create these tasks to like kick them off. And that's pretty interesting, right? Like that's not super obvious, I think. Normally when you call a function, it does a thing.
Yeah.
But here, not so much. So some other options, if you could call them both as create them as tasks, and then you could await those tasks, right? Because their tasks are already running, and then you await them both, whichever one first finishes first, doesn't matter. You wait till the first one's done, and maybe the second one's already done. So that's probably the pattern that most people are going to be using. But you can also use async IO gather that takes one or more awaitables as a star args, and then it waits for them all to finish, which is pretty cool. And that itself is a future thing that you can await, right? So you would say await async io.gather.
Oh, that's cool.
Bad. Bad spam calls. Sorry, Brian. And
No,
everyone on
I think,
YouTube. That's how it goes. The podcast life. All right, back to this.
no,
So
Gather's
Gather's cool.
Gather's
But
looks pretty cool.
yeah, Gather's awesome because I can create all these tasks and I say, I just need them all to be done. And when that's done, we can get the results and carry on. And what's cool is when you await Gather, you get a tuple of results. So if I say asyncio gather function 1 or task 1, task 2, then it returns the result 1, comma result 2 as a tuple. So you can gather them up and get all the answers back, which is pretty cool.
Yeah. That's really neat.
Yeah, one of the problems with Gather, though, is you're saying, I'm willing to wait forever for this to finish. And sometimes that's fine, but sometimes things don't return correctly or ever or in the right amount of time. So you can use wait for, which is nice and allows you to pass a timeout. But what's a little bit better than a wait for is there's an async timeout package on PyPI, which I'd not heard of. And you can basically create a block that will, a with block that will time out. So you can say, I want to have an async with timeout 5 seconds and then do a whole bunch of function calls and awaiting and all that. And either they're all going to finish or when 5 seconds passes, everything gets canceled that hasn't finished.
Oh, that's cool.
That's pretty cool, right?
Yeah.
Another one that's really interesting is I start a bunch of work and then I would like to say I kick off, I'm doing web scraping and I want to go get the results of 20 web pages. I kick off 20 requests and then I want to process them as they complete. Like the first one that's done, I want to work on that. Then the next one, then the next one. So you can create a task or an iterable rather from saying asyncio dot as completed and you give it a bunch of tasks and it gives you an iterator that you can for in over that gives you the first completed one, then the second completed one, and just blocks until the next one is completed. So you kick a bunch off and then you just say for completed task in asyncio as completed and you give it your running tasks. That's really slick, isn't it?
That is slick. Looks like it has a timeout also that you can add to it.
Yeah. Very, very nice. Yep, you can give it a timeout indeed. Now, there's a few more things covered in there, and I didn't go over the trade-offs too much. You know, here's the scenario where you use this and that. So if you really care about this, two things to do. One is check out the article. It's got a lot of details, and each subsection has a little trade-offs. Here's the good, here's the bad, which is nice. And also, you can check out my async course, which talks about this and a whole bunch of other things on async as well. So, you know, I'll put a link in the show notes for that as well. Thank you for watching this segment of the Python Bytes podcast. This video was made during the recording of the full episode. Visit pythonbytes.fm and get the whole story. Subscribe to the podcast and get the entire episode delivered to your phone. Please support our work by taking one of the courses at pythonbytes.fm/courses or learning PyTest with Brian's book at pythonbytes.fm/PyTest. Finally, visit our sponsor shown on the screen here. Visit the link on the screen and get the special offer for Python Bytes and YouTube listeners. Thanks, and have a great rest of your day.